Hello, my name is Collins. With this video, I intend to demonstrate the concept of inter-VLAN switching and inter-VLAN routing. Now, this demo is solely dedicated, or say especially dedicated for those who are new into networking and for those new into networking who are finding it hard to understand the concept of inter-VLAN switching and routing. Now, looking at this topology, we can see that this is a topology made up of three VLANs: VLAN 10, VLAN 30, and VLAN 20. But before I go further, I would like to define the concept of VLAN. What is a VLAN? Well, a VLAN is a virtual network. It is a logical segmentation of a broadcast domain. This whole topology as a whole is a single broadcast domain without the VLAN. What this means is that without this VLAN, if PC1, for example, were to send a broadcast message, every single device in this network is going to receive that packet of frame. But by implementing VLAN, we can logically divide this broadcast domain such that every device could associate with a VLAN. And so, if PC1 were to send a broadcast frame, only devices which are connected to an interface associated to VLAN 10 will receive that broadcast frame. So, I hope this is already understandable. And to mention, this demo is not going to include configuration. I only intend to make a very simple demonstration to demonstrate how traffic moves between VLAN and how switch forwards a packet. So there are several importance of segmenting the network, and aside from being cost effective, it is also used to enforce security measures in a network, or let's say in a local area network. For example, if VLAN 30 were to be a guest network and VLAN 20 is a finance department, belong to the finance department, devices in this VLAN would not be able to communicate with each other without going through the router. And if the traffic has to come through the router, we can control what traffic is allowed into the finance network. But without segmenting the network traffic, we have to move through the switch, which is a layer 2. But by segmenting the network, the traffic can move using the layer 3, that is a router. I hope this is understandable. Now, I'm going to ping PC4, that's a PC6 from PC1, and we're going to watch how the traffic is going to move within the network. So without a VLAN, as I mentioned earlier, every single host in this broadcast domain will receive that broadcast frame. But because the hosts belong to separate domain, only devices that associate to VLAN 10 are going to receive the broadcast packet. Now, in this first ping, PC1 has not learnt the MAC address of PC6 because devices on a local area network communicate with each other on the layer 2. That's the link layer using the MAC address. So let's start a ping to monitor the traffic. I'm going to open the PC1 and I'm going to go to the desktop and the command. So we will go into simulation mode and PC1, and then we will ping PC6, ping 10.0.0, 10.4. So we'll start the ICMP echo request, and as you can see in the simulation panel over here, PC1 has created the ICMP packet, but because it does not have the MAC address of PC6, it's going to opt for the MAC address. So let's watch how the app frame is going to move within the network. So I'm going to forward this step by step. So now the frame is going to go to switch 1, and from switch 1 it goes to PC2. PC2 drops the packet because it's not the right host. It goes to switch 2, it flows the frame to PC1, that's the interface 0/2 and the interface 0/1. So the packet is now at switch 2, and it goes to the router, the default gateway, PC7 and PC6. So we can see what happened here. Devices in VLAN 10 and VLAN 20 did not receive the frame. This is because they belong to a different VLAN, to a different network. So the frame only forwards the packet, that's the frame. The switch, only forwards the frame to interfaces that are configured as VLAN 10. And now, the same way, PC6 is going to send the MAC address back to PC1, and the ping will start from there, as you can see. So now I'm going to close these. What I'm going to do is try to ping an end device that belongs to a different VLAN. Let's say VLAN 30 from PC6. I'll reset this, and I'll go to the console of PC6, and I will go to the command prompt, and I'm going to clear it. So what I'm going to do is I'm going to try to ping this one time so we don't have to wait for the app request. I will go to the read time, and I will ping this for the first time so we learn the MAC address of the default gateway, because I just want to demonstrate how the packet is going to go through the router. Ping 10.0.0. So let's say PC4, which is a 130 IP address of 130. So now the first time's out, of course. So now the app has done its work. I will close this. I'm going to ping PC30, PC4, but now in simulation mode. Alright, from PC3, I will start the ping request. Okay, so let's see. Now the ping echo request is going to start from PC6, and we're going to see. So it goes to the switch, and then to the default gateway, and in the default gateway it goes back to the switch 2, and then to switch 1, and then to PC4, and PC4 is going to send back the echo reply. The traffic is going to move in a reverse way back to PC6, and as we can see, if a device that belongs to a separate VLAN tries to reach a device that belongs to another VLAN, the traffic is going to be routed through, is going to be moved to the router instead of the switch. So this way we have control over the frame or the traffic that comes into any of the network. Now this is the concept of inter-VLAN switching and inter-VLAN routing. I hope this is very clear. Hopefully in my next demo I'm going to record the configuration step. But for today, I think this is enough to understand the concept. And by the way, before I end this video, I'm going to make this comment and confirm that this point-to-point between the two switches is a trunk port. They are configured as a trunk port to allow traffic from VLAN 10 and VLAN 30 to come through this interface, and here as well. And so if we were to add, for example, a different device to another interface which does not belong to any VLAN, that traffic is going to be routed through the native VLAN. That is a VLAN 1. Okay, so for security reasons in production, we create a VLAN that is not in use. And so traffic that does not belong to any of the VLAN which are configured by us is going to be forwarded through that native VLAN, and it goes to nowhere. So I hope this is very clear and understandable, and I hope you understand this. So if you have questions, please leave your question in the comment section. I'll be really very happy to clarify.